Okay, and with this game, where you have a 0.1 probability of winning and a 0.9 probability of losing, we're going to play it 3 times. Okay? So here's what's going on. And we're going to assume that the outcome of this game, whether you win or lose, does not depend on whether you won or lost before. So you have a fixed number of trials, 3 times that you're playing. That's your 3 trials, fixed number. These trials are mutually exclusive because the outcome of one is not affected by the outcome of the other. And each of those trials ends in one of two mutually exclusive outcomes. Either you win or you lose, not both. So, fixed number, 3 independent trials. Each time you play the game, it's independent of previous plays. And each of those trials ends in one of 2 mutually exclusive outcomes. Either you win or you lose. So, this situation qualifies for a binomial distribution, and this is what the binomial distribution can tell you. The probability of winning a particular number of times. So let's say we want to know what's the probability of winning once out of 3 times. Okay? Well, there's different ways that you can win once. So now I'm going to use W to represent winning and an L to represent losing. What does it mean to win once? Well, you're playing 3 times. So winning once means the probability of winning and then losing and then losing, or losing, then winning, then losing, or losing and then losing again and then winning. That's what it means to win once. It means one of these 3 situations happens. That's the only way you win once. And all of these situations are mutually exclusive. You can't have both of them. You only exist in one timeline. Either you win and then you lose twice, or you lose and win and then lose again, or you lose twice and then win. If you're winning once, then you're in one of these 3 situations, and only one of these 3 situations. They are mutually exclusive. And if you recall above, when outcomes are mutually exclusive, the probability of one or the other, it's just the sum of the probabilities. Probability of one plus the probability of the other. Easy way to remember, if you have independence and mutual exclusivity, or means plus, and means multiply. So, because of mutual exclusivity, this statement can be rewritten as the probability of winning, then losing, plus the probability of losing, and then winning, and then losing, plus the probability of losing, and then losing, and then winning. Now we're going to expand this. This first term here, it's the probability of exactly what I just said, but I'm going to put it in more technical terms. Winning, and losing, plus the probability of losing and winning and losing, plus the probability of losing and losing and winning. That's what that means. If you win and then you lose twice, it means you won and you lost and you lost. All three of those occurred. Or you lost and you won and you lost. All three of those occurred. Or you lost and you lost again and you won once. Now let's look at that first term here. You win and you lose and you lose. Remember, each trial is independent, which means this loss here, the probability of that loss is independent of whether you won or lost the first time. And the probability of that second loss is independent of whether you won or lost the first two times. And we're looking at the probability of one event and another event. When those events are independent, we just multiply the probabilities of those events. So now we'll rewrite this again. Equals the probability of winning times the probability of losing times the probability of losing plus the probability of losing times the probability of winning times the probability of losing plus the probability of losing times the probability of losing times the probability of winning. That's a lot of writing, so we're going to write that down a little bit more cleanly. The probability of winning times the probability of losing squared, because we multiply it by itself, plus the probability of winning times the probability of losing squared, again because this term has the probability of winning multiplied by the probability of losing twice. So again, it's probability of winning times the probability of losing squared. And that third term, probably notice the pattern. Again, you have the probability of losing squared because of two probabilities of losing, and then you're multiplying it by the probability of winning. Now look at this. We have the same thing 3 times. Right? Just want to make it a little more clear. Two probabilities of losing, again 2 probabilities of losing, and again 2 probabilities of losing. That's why we have a probability of L squared every time, and only 1 probability of winning every time. Remember, you can multiply in any order. So, if we have the same thing 3 times, we can just write it like this. Three times the probability of winning times the probability of losing squared. Okay, now this is a particular case of the binomial distribution. The general form of the binomial distribution is like this. Where does that 3 come from? Well, that 3 is the number of ways that you can get one victory. That's what we calculated at the very top. Win once. It can be done like this, win, then lose, or like this, lose, then win, then lose again, or like this, lose, then win. So 3 is the number of ways that you can win once. So what's actually going on here is number of ways to win once. And then you have it multiplied by the probability of winning to the power of the number of wins. Because this here, you can imagine it as a to the power of 1. And then we multiply that by the probability of losing to the power of the number of losses. And the general form of the binomial distribution looks like this. The probability of x successes is n choose x. Okay, this is not a fraction. This is a different kind of symbolism, which means the number of ways you can have x victories given n trials. In our case, that's 3, the number of ways you can have 1 victory given 3 trials. So n choose x. You multiply that by the probability of winning to the power of the number of victories. Remember, x is the number of successes. There's that x up there. Probability of winning, right here, multiplied by the number of wins. And then we multiply that by the probability of losing, which is 1 minus p, lowercase p, to the power of the number of losses. Well, the number of losses is going to be everything else. Okay, if you have n trials and x of them are successes, well then the rest of them, n minus x, are going to be failures. Okay, so again, p is probability of winning. And in any situation that satisfies the conditions for a binomial distribution, that's a fixed number of independent trials where each trial ends in either one or the other mutually exclusive condition, you define one of those conditions as a win, you define the other as a loss, and you can calculate the probability of a certain number of outcomes. Okay, so in our case here, the probability of 1 victory, which is what we were looking for, given 3 trials, we had 3 choose 1, times 0.1 to the power of 1, times 0.9, which was our probability of losing, to the power of 2. So the number of ways you can win once, that's our 3 choose 1, times the probability of winning, 0.1, to the power of the number of wins, 1, times the probability of losing, 0.9, to the power of the number of losses, 2. And if we calculate what that is, I'll tell you what 3 choose 1 is later, or how to calculate it, but it is equal to 3. 0.1 to the power of 1 is 0.1. And 0.9 to the power of 2. And you would just do this on your calculator on a test, if need be. Or maybe you just know it, is 0.81. And then you calculate that. And you will get 0.243. So if you have a game or any situation where the probability of victory is 0.1 and the probability of failure is 0.9, and you want to know, well, if I repeat this situation 3 times, what's the probability that I will see exactly 1 success? The answer is 0.243%. The probability is 0.243 or about 24.3%. So, let's look a little bit closer at that general case. So, let me just move down here. So what is this n choose x? The number of ways that you can pick x items out of a set of n, or the number of ways that you can pick x victories out of a set of n attempts. So for 3, this was easy to do. 3 choose 1. We want to know what that is. We can just list it. A win, a loss, and a loss, or a loss, a win, and a loss, or a loss, and a win. But if we have something more complicated, let's say 5 choose 2. 5 attempts. In how many ways can you get 2 victories given 5 attempts? Well, it's a little more complicated. Okay? You can have a win, and the rest are losses. You can have a win, a loss, a win, and 2 more losses. A win, a loss, a win, and then a loss. A win, a loss, a loss, and then another win. And we're not done yet. You could also have a loss to begin with, and then 2 wins, and then 2 losses. A loss, a win, a loss, a win, a loss. A loss, a win, a loss, and a win. You can have 2 losses, and then 2 wins, and a loss. You can have 2 losses, a win, a loss, and a win. Or you could have 3 losses, and then 2 wins. Now I believe that's everything. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 possibilities. And that took us a while to count. And that's just 5 choose 2. Imagine there were 100 trials, and we want to know the probability of 20 successes. It would take a very long time to calculate. So, I'll show you what's actually going on, and then I'll tell you how to do it on a calculator. N choose x is n factorial divided by x factorial times n minus x factorial. If it seems overwhelming, don't worry. There's a quick calculator way to do it. Now, what is factorial? Well, any number, factorial means 1 times 2 times 3 times 4, and so on up to times that number. So for example, 5 factorial would be 1 times 2 times 3 times 4 times 5. So 1 doesn't really affect anything. 2 times 3 is 6. 6 times 4 is 24. And 24 times 5 is 120. So that would be the answer. So for example, 3 choose 1. Well, that would be 3 factorial divided by 1 factorial times 3 minus 1 factorial. Okay, so that's 3 factorial divided by 1 factorial times 2 factorial, or 1 times 2 times 3 divided by 1, that's the 1 factorial, times, and 2 factorial is just 1 times 2. Well, the 1's don't do anything. The 2's will cancel out, and we just have 3. Our second example was 5 choose 2. A bit more complicated. So we have 5 factorial divided by 2 factorial times 5 minus 2 factorial. So that's 5 factorial divided by 2 factorial times 3 factorial. So we have 1 times 2 times 3 times 4 times 5 divided by 1 times 2, that's the 2 factorial, times 1 times 2 times 3, that is the 3 factorial.